Hello, Algebra 1 students. Mr. Ford here with a homework tutorial, the first one for Chapter 4, 4.1.1, problems 4.8 through 4.13. 4.8 is a monster problem. We're going to do this together in class, so many of you who will already have the answer to this one, but for anybody who doesn't, let's talk about how to set up this scatter plot. First of all, this column here is going to, the first row is going to be X, second row is going to be Y, the AP score is going to go along the X axis down here, and the percentage along the y-axis. This is not an instructional video, just an answer guide. I'm going to place 1, 2, 3, 4, and 5 for the AP score along here, and the final exam score over here, which I'm going to count by 10s. 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Now, all we need to do is to place these points on the grid. 597 is going to be somewhere up here. 170 is going to be somewhere right there. 484 right there. 266, this process is the most fun part. 162. 479. 273. 163, right in the middle there. 382. And 590. Now, at this stage, you're going to want to grab some sort of straight edge tool like this. It won't really matter. You're going to just kind of place your line kind of as best as you see it through that data. It doesn't need to touch any of the points on it, but it should be just a line that kind of makes sense. That's the most artistic you can be about it. We are going to need to find the equation for the line of best fit, so we're going to do exactly that. We're just going to make an mx plus b equation. And we're going to have to use our line. Now, b in my equation looks to be a little bit more than 60. I'm going to say 62. There's no exact science here, just guess. As far as the slope goes, I'm looking for lattice points, points that are right along the grid. And for me, I think I see grid points. Maybe I'm just eyeballing there and there. So I'm going to draw a slope triangle on my line. Now you got to take into account your scale. This is not 2 over here, it's actually 20. Let me make that blue instead, actually. Because each up and down box is worth 10. And every 2 boxes here is worth 1. So that's 1, 2, 3. So I got 3 down below. So my slope is 20 over 3, which I'm going to reduce down. Actually, 20 over 3 is pretty good. That's 6 and some change. So I'm going to call my slope 20 over 3 times x plus 62. There's my equation. And as far as estimating what a student who scored a 3 on their AP test would get, I would do y equals 20 times 3 plus 62. And in this case, the 3's actually cancel out, and 20 plus 62 is about 82, so I'm guessing that somebody would get about 82. Now, if I see this exact answer on your homework, I'm going to know that you just copied my answer down, so I'm not going to give you credit for this problem. Please make sure that you do this problem on your own as best as you can. You are worth it, and you can do it. Down below 4.9, let's solve for x here. First problem, we're going to need to do the distribution first. That'll be negative 8 plus 6x minus 6x equals 10. I notice right away that the 6 x's are going to cancel out. So what we get here is negative 8 equals 10, which has no solution. So there is no x that would make that equation true. Over here you have a fraction problem. The best way to handle this problem, I think, is to look at negative 2 and negative 3 and figure out the least common multiple of those two numbers, which I think is negative 6. And I'm going to multiply the entire freaking problem by negative 6. And I think you should do the same thing too. There are other ways to solve this, but this is, in my opinion, the best. And it sets the stage for a checkpoint quiz, which is coming up. Now what's going to happen here is that this negative 6 times divided by negative 2 will put a 3 out in front of x minus 5. And it will put a 2 out in front of x minus 1. Like that. The negative 6 divided is going on here. Negative 6 divided by negative 2 is 3, and negative 6 divided by negative 3 is 2, and that's where those numbers came from. And now it's a pretty straightforward problem. 3x minus 15 equals 2x minus 1, and when you subtract 2x from both sides, that's nice because the x's just kind of combine to make 1x. X minus 15 is negative 1, and we add the 15 over, it's going to be positive 14 for the answer, and there you go. I should show my work, I guess. This is an answer guide, might as well. Plus 15, like that. Going to the next page, we got on the same set of axes, use the slope and y-intercept to graph each line in the system shown below and find the point of intersection. This is what we're doing in Chapter 4. Systems of equations. We're finding the solution to this system. Let's start with the first line. Has a y-intercept of 2. I'm putting that right on there. And a slope of -1. So I'm going to go to the right one, down 1, right one, down 1, right one, down 1. And so, making notes, -1, slope, y-intercept is 2. So that's that line. I'm just going to kind of freehand it right now. You can use a ruler for this if you want to, but you can probably freehand it pretty nicely. It's not too terrible to do. The next line, which I'll do in purple, I suppose, has a slope of 3 and a y-intercept of 6. So I'm going to go over here and put 6 on the y-axis, go to the right 1 and up 3, next point, or go back 1 and down 3, and that's the point of intersection right there. You can see where they cross. Boom. That point is -1, 3, and that is the solution to this problem. That is that question. Pause there if you want to. Next question. 411. A team of students is trying to answer the scientific notation problem. 2 times 10 to the 3rd times 4 times 10 to the 7th. Jorge thinks they should use a generic rectangle because the 2 terms are multiplied by 2 terms. Yeah, he's wrong, though, because those are not plus signs. If those were plus signs, he'd be 100% correct. So Jorge is out. Cadell thinks the answer is 8 times 10 to the 10th, but he can't explain why. And Lauren thinks they should multiply the like parts, and her answer is 8 times 100 to the 21st. The mistake that she has made is multiplying 10 times 10 to get 100. This is 10 to the 3rd and 10 to the 7th. Another way to think about 10 to the 3rd is 1,000, and 10 to the 7th is, let's see, I guess 1 million. 10 million, like that. So she's also mistaken. She's multiplying the zeros when she should be adding them. Cadell is actually correct. We should be this is just 4 things multiplied together. If I rewrite it a different way, it's 2 times 4 in the first chunk times 10 to the 3rd times 10 to the 7th. 2 times 4 is 8. And if you think about your exponent rules, you can just add together the 3 and the 7 to get 10 to the 10th power, and that's the answer. So Cadell is correct. 412, for each following generic rectangles, find the dimensions and write the area as a product and a sum. Let's go ahead and write the as a sum right now. 3y squared minus 12y equals. Over here, we'll do 3y squared minus 7y minus 20. The minus 7y is coming from 5y minus 12y for anybody who's interested. All we got to do now is think about the dimensions, and for that, I like to go across the rows of the columns and look for what they have in common. 3 and -12 both are multiples of 3, and they both have 1y in them. So that's the common multiple there. Up top, you got to think about what you multiply. 3y times y gives you 3y squared, and 3y times -4 would give you the -12y. And so that's how I know this is also 3y times y minus 4. We call this process factoring, and what we're doing is we are, in the verb form, we are factoring out a 3y. Over here on question B, very much the same thing. Basically pick any row or column you want to work with and factor things out. You might notice that the top row is exactly the same as the top row as the previous problem. So that's going to help us out quite a bit. In fact, we can go ahead and just copy our answer from the previous problem right now, y minus 4. Which means we really only have to think about the bottom part, which has to be 5, because 5 times y is 5y, and 5 times -4 is -20. And so as a product, the answer would look like this: y minus 4 times 3y plus 5. Finally, 413, a prime number is defined as a number with exactly 2 integer factors, itself and 1. Jeannie thinks that all prime numbers are odd. Is she correct? She's not. If so, state how you know. Here are the list of prime numbers: 2, 3, 5, 7, 11, 13, not 15, 17, 19, not 21, 23, not 25, not 27, not 29 is, though, I think, at least. Prime numbers cannot be divided. They only have 2 divisors, themselves and 1. However, there is one even prime number, and it's the number 2 in front, and this is why Jeannie is wrong. She's so wrong that you can even spell it wrong. She's wrong with a capital R. All the other prime numbers, though, must be odd, though. Otherwise, they could divide by 2, but 2 is an even prime number. And that's the end of this homework tutorial. Thank you for watching. I'll see you in the next video. Don't forget, you are awesome.